Thanks to everyone who is gathered here. So today's topic is going to be about signal boosting. So this is going to be about an interesting library called signals and how we are going to be like using it with React. Okay. So a little bit about myself. So currently I am working as a software engineer in Undagraph. And Undagraph is like this amazing API gateway, which is like a programmable API gateway where you can connect all your data sources and you can get instant GraphQL endpoints. And other than that, I work with React, React Native, and obviously I work with lots of GraphQL tools. And I prefer writing my backend in serverless and edge runtimes because they are like just too cool. Next, let's just go into the talk. So we'll start off with learning what is virtual DOM. So I'm pretty sure at this point everybody here would have like learned about virtual DOM because we are in React Nexus, and React, when it came out, it was known for its virtual DOM. So when you look at virtual DOM, right, it is really fast. But currently, as the amount of our application components started growing, it is fast for most cases. So how many of you have been like building React applications and over a period of time, you start seeing your application get laggy? I'm pretty sure like most developers here would have like noticed their application get laggy over time. And this is like a common phenomenon. Usually this happens due to like one of these two reasons. One, the amount of JavaScript that you are shipping increases in size, which means you will be like doing lots of lazy loading, like code splitting, and of course React Server Components. So React Server Components, it's like an excellent solution. Basically it removes all the JavaScript and lets you ship direct HTML to your users. And the second reason will be the main thread getting blocked a lot. So this is common when you are like building applications on the scale of Figma, Google Docs. So in my case, I ran into this problem when I was building a rich text editor. So I was like building a rich text editor which pretty much like renders every single text as its own DOM node. And what happens is, as I am like building things with the virtual DOM, even like one small change actually causes a pretty big render throughout the DOM node. So let's understand like how React DOM like handles its renders. Okay, so let me start off with a code example. So this is like my store that I have for like building a list of to-dos. So let me just walk you guys through the store, how it works. So at the top you have like the ID, and you also have a list of to-dos, and you have listeners. Listeners is basically going to be an array of parties who are interested in knowing when the state changes. So for example, you have like an application with 3 components which actually shows 3 to-do items. Each of these components are actually interested parties. They are all the listeners for the store change. So now we have this subscribe function which is part of React's use sync external store hook. So we'll just skip over the subscribe part and we'll just look at what the add to-dos does. So whenever like you are adding a new to-do, a new to-dos object gets created. And also on line number 8, you will notice that it is emitting a change. So this is a function called emit change. So what happens in that function is that it will go through all the listeners, all the interested parties. Whenever there's a change happening, it will go through all the parties and it will simply say, hey, something has changed. So it doesn't actually like give what changed or is it actually a change, but all it knows is somebody tried to add a to-do and I actually have to like inform the listener that, hey, something has been changed, you just take care of like the virtual DOM renders. So here is where things get interesting. So what happens when this listener gets fired is that a new virtual DOM re-render starts happening. So what React does is, React will have a previous DOM tree reconstructed in its memory. Now, when it actually knows that a change has been happened, it has to like reconstruct a newer version using JavaScript. And remember, this reconstruction actually is happening on the JavaScript main thread. So the moment a main thread activity starts, you will actually see the other processes getting slowed. So this is fast when your application is small, but when your application is growing in size and you have hundreds of components, and in some applications I have seen thousands of components, constructing the entire virtual DOM, even for like slight DOM changes, actually starts adding an overhead. So this was a blog post, interesting blog post written by the Svelte community, like how virtual DOM is a overhead. I highly recommend everybody to read. It's part of the slide. Now let me show you in practice like how this virtual DOM actually does its re-render. I have in here a simple box component. Okay, and this box component actually has an animation. So this is a smooth animation that just moves around. What's going to happen is every time a virtual DOM recompute happens, okay, it will cause the animation to reset. And to trigger that reset, all I have to do is I'll just do a small slider across it. So every time like a re-render is happening within that component, it actually like causes the box to jitter around. And I also have like a selected flag, which basically like selects the box. Whenever a target box gets selected, it will turn red. Now let's simulate a real world experience using this. So what I'm going to have is, I built a set of boxes using context. So React context is like a most common way to like share state across the entire DOM tree. I can also like walk you guys through the code. So this is the context catalog that I have. So if you look at the box itself basically accepts like three props. It accepts ID, value, and is it selected or not. And if you look inside, it basically has an animation function written in framer motion, and it also has like one small transform. So what I did is I put this transform on the main thread instead of putting it inside use effect, which means every time React is like reconstructing this component to check if it has changed or not, it actually like triggers a reset of its animation. Now let's look at the context catalog, like how I have built this context. So this box context has like an ID, value, and two setters for updating its ID and its value. Then I simply like looped over this box in an array of 100 elements. So I just like generated like 100 separate boxes and basically gave ID to each of them. So this is like the parent component, which basically like renders 100 boxes. Then you also have like the actual animated box component, which is basically like the way it extracts the data from the context. So this component extracts the data from the context and checks whether I am selected or not. And if I am selected, the value inside the box has to change. Okay? So let me show you how it will look like. So I'm going to select box number 7. So the box number 7 just got selected. And basically when I do modify the slider, the number inside the box will start to change. And also you should remember here, whenever there is a re-render or any unnecessary re-render happening within the virtual DOM, the animation of the boxes are going to reset. So using context, what happens is that you can actually see the entire DOM tree is like re-rendering. Now what you have to note here is the actual DOM didn't change, only the internal React's computation is like trying to recreate the DOM element and do an equality check. So this is a pretty fast activity because it happens in the virtual DOM. It is not blocking your main thread as much as directly doing inner HTML and updating your DOM. But still, as your application is scaling, this adds a slight overhead. And also, like adopting React server components or adopting any new technology requires you to like rewrite your entire application architecture. So how we can like quickly get a win over this area by like making the states little more efficient. So first thing what I did is, instead of context, like the most recommended thing is use a state management library that is like super efficient. So what I did is, I re-implemented this entire animation using ZooStand. So ZooStand is like my most favorite state management library, which lets me like declare states outside of React component and use it universally across my application. So here we have the implementation of ZooStand. So it looks the same. Instead of like context, I used a ZooStand create utility and created a hook, my state hook. And using the state hook, I basically just assign a value and set and select and change the value of my box. And the code will look a lot similar. So now, what happens here is, I still have the array of 100 elements, like the 100 boxes being rendered with the animation and everything. But this time, there is no parent wrapper, like provider or like a common state across its children. So what Zustand did is, it actually like made the entire state like decentralized. And then only in the child element, Zustand actually like tries to get the state value back. So in this scenario, what happens is that with the Zustand implementation, say I am selecting ID number 8, it actually like optimizes the virtual DOM comparison by making sure only the required box is like re-rendering. So all the other boxes are like safe. So this immediately gives you a pretty significant boost over how you are like updating the state using context. But still, why is it that context, Zustand, all of them requires like recomputation of the DOM when I just actually want to like change that one single number, because I don't actually care about all of my component or anything, I just want to change small element in the DOM. So let's talk how signals work here. So this is the code, at least like a sample code of how signals work behind the scene. Not the detailed one that covers all the edge cases, but a simple, easy to understand. So if you look at signals, right, it has two things, a setter and a getter. So what happens is, whenever you want to like set some value, you initiate a setter in the signal. But when you are like getting a value, you don't call an object or value, instead you call a function. So this is different from React state, where you use a state as a value and you use setter, which is a function. So going by this approach, what happens is that whenever you are like getting some value, you actually put a function in the place where the value is residing. And whenever you are like setting a value, you are calling that specific function. So you are no longer bound to a React component, but you are now directly bound to a DOM element. So what happens now is, every DOM element that you are like adding using signal now has a listener attached to the element directly. So this goes against like how virtual DOM recommends, like do all the diff on the DOM element. But if your goal is to like directly edit an element and don't trigger like a lot of process on the main thread, signal basically like overcomes all of that and directly does fine-grained optimizations on your DOM. So let's see how the signal implementation performs. So this is my signal implementation. So basically every DOM number in this boxes basically is now a independent signal that is like having its own event listener. Now let me select an ID. This time I'll go with 4. So I have selected 4. Now if I just slide my container, you can actually see there is like no re-renders triggered throughout my virtual DOM. So basically it went and started directly like affecting the actual DOM node. Now signals is not a permanent solution for any of the performance fixes. Signals are great when you have like huge DOM nodes and you have to like make fine-grained changes to specific DOM elements. In my case, having a rich text editor is the perfect scenario, because rich text editor has lots of DOM elements and I had to like make changes to specific items. Say I want to make specific text bold, I want to make specific text underline. This actually worked really well in that. So this idea of signals is like introduced by Solid.js. Right now it is available in React, and I would highly recommend everybody to like give signals a try. It's part of the Preact set of tools. It works with React as well. And pretty much all the stuff I have used in this talk have been like listed out. I'll just share this presentation in GitHub. And finally, that concludes my talk. Cool. You can connect with me on Twitter. And if you guys want to like know more about signals, feel free to reach out to me. I'll just be like hanging around here. Cool. Thank you guys.